identifying data structures. Why is it necessary to identify these data structures? Well, as an R programmer, it's important for you to know how to identify and represent the data in R before you start to analyze it. There are 6 primary types of data structures. As I go through these throughout this section, I'll let you know which ones are more prominent in the field today. But as to the 6, there are atomic vectors, matrix or matrices, arrays, factors, data frames, and list. So why do we have all these different types? Well, they handle data differently. And so let's say an atomic vector. So there's 2 aspects that we have to consider in regards to the data structure. The first is type, the second is dimensionality. So if you ever hear the term scalar, that is a quote-unquote 1-by-1 matrix. With a vector, the dimension is still 1, but it can be 1 by many. So let's say we have the ages of the students in a classroom. That would be a vector. And the reason why is because age is a single column, and then we have homogeneous data. So homogeneous data means it's the same data type, the same data class across all of those values. Now, if we didn't have homogeneous data, then we have heterogeneous data, correct? So a list is like an atomic vector, except it can be heterogeneous. So we could have the number 19 along with the name Sally, along with that her favorite food is pizza and her class gender is female. And all these are different types, and that cannot be set in a single instance within a vector, so we have to have heterogeneous, hence the list. Factors are similar in that they only have certain classes or values. So gender is a factor because it will generally be classified as male or female. When we look into dimensionality, we have matrices, arrays, and data frames. Now we'll get into the difference in these, but a matrix is homogeneous and has 2 dimensions. So if you think of an Excel file, but everything within there is numeric, that's a matrix. An array also has to be homogeneous, but it can have as few or as many dimensions as we want. So we could have 1, 2, 3, 4, 5, infinity number of dimensions. But again, that's homogeneous. Now, factors are a one-dimensional, a vector of homogeneous data types. Factors are essentially categorical values represented in a numeric schema. And then a data frame will be the data structure that you're most likely to work with. And that's more like an Excel file that, or a SQL data warehouse that contains all customer data. Sales purchases, their name, age, credit card information, because the data types are heterogeneous, but the dimensionality is still 2. So, going through these, we'll start at atomic vectors. An atomic vector is a one-dimensional object, the simplest data structure. It's called an atomic vector because all the elements within it are of the same type. So, we could talk about the different types as numeric, integer, character, or logical. So numeric and integer are relatively the same. Numeric can include decimal points, whereas integer cannot. So if you look at example, the first one, if we create a vector called A and concatenate 1, 2, 5, 3, 6, negative 2, and 4, that's an integer data type atomic vector. The second one, B, we're concatenating 1, 2, and 3, but because of those quotes, you see they're strings. And so that's a character data type atomic vector. Note that everything is the same within that vector, just like the first one. Lastly, you can see C, we're concatenating true, 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 false, true, false. And this is a logical data type. Logical data types always contain simply true or false. When you're working with an R, if you're looking to easily create a vector of consecutive numbers, you can use the colon operator. So when we say 1 colon 5 and assign that to X, and then if you see after the semicolon, we have X. In R, you don't have to use the print command, so you can. This is basically saying to print X after we assign this value operator. And that shows that 1, 2, 3, 4, and 5 were created. Just like with Y, if we have the range from 1 to negative 1, that will include 1, 0, and negative 1. It is inclusive. So when we're looking at indexing elements, vector elements can be accessed by vector indexing. And vectors can be numeric, character, or logical, as we described earlier. Now within R, vectors start at 1 instead of 0. An individual element of a vector is accessed by its position, which we indicate using square brackets. So if you look at vec C, A, B, C, D, E, F, when we say vec1, it will return the character string A. The one below that, when we say vec C24, it will return B and D. Now, if we had used a column, it would or colon, it would show B, C, and D. And if you notice the numeric or pound sign or hashtag, that's how we use commenting within our software. So that will be grayed out in R Studio, or whatever IDE you're leveraging. And so when you're writing notes to yourself or other data scientists to show what was done, you can use this commenting out, and that doesn't actually run anything. So it can be used for explanation. The second type of data structure is a matrix. It's a two-dimensional data structure. It's similar to a vector, but it has a dimension. Again, everything has to be the same class: numeric, integer, character, logical. In this vector, we're putting together 1, 2, 3, and 4. But let's say we want to convert that vector into a matrix called foo. So we're taking that vector input, and we're specifying that we want 2 rows, n row, and 2 columns, n col. And so what foo will return is 1, 2, 3, 4, but in matrix form, a 2 by 2 matrix. Now it's important to note that elements in a matrix must be of the same type, whether that's a number, character string, or Boolean. So the values for the rows and columns are assigned using nrow and ncol arguments. Now, at base, if you don't include an assignment, matrices are filled column-wise. So in this example, you can see we wanted to create a matrix with the numbers 1 through 9 and have 3 rows and 3 columns. Now, because we specified by row equals true, it is filling that by row. So you see 1, 2, 3, 4, 5, 6, 7, 8, 9 across. However, if we didn't include that, or we had by row set to false, then 1, 2, 3 would be in the first column, 4, 5, 6 would be in the second column, 7, 8, 9 would be in the third column. And again, when we're wanting to access elements, they're accessed using the square bracket indexing. So in this case, we're looking at C1, 2 and C2 and 3. So rows are first, so we're selecting rows 1 and 2, which would include 1, 4, 7, 2, 5, and 8. And columns 2 and 3, 4, 5, and 6, 7, 8, 9. And when we bring those together, that would produce the output of 4, 5, and 6, 7, 8. Arrays are similar to a matrix, but can have more than 2 dimensions. So here you see an array, 1 through 24, and you're looking at x by y by z dimensions. So essentially, it's a little bit harder to visualize this because you're kind of thinking of it as stacked Excel files. I know this can be overwhelming, but I'll try to go through this as simple as possible. So the arrays are taking these vectors as inputs into the matrix. And then the rows and columns are named using the dim names parameter. So we have these 2 vectors, vector 1 and vector 2. We specify the column names and the row names. And then we also have the matrix names. So when we look to output that, you can see what that output is below. So using the index position, one can access or change individual elements in an array. Again, we're using the brackets. And so if we wanted to print the second row of the first matrix of an array, we would use 2, 1. And with arrays, you have to use 2 commas as opposed to, say, like a matrix where you're using a single comma to denote the row and column. Now with factors, it's essentially a class value system. So we're taking a predefined finite number of categorical values. So if we were looking at gender, the levels of that would be female and male. And the way we can create factors is using the factor function. The way to validate that something was created as a factor is using the class function. So if you use class on this, then it will produce something that shows that it's as a factor. And then if you wanted to show the levels within that factor, it will produce male and female. So accessing elements of the factor is similar to accessing elements of an atomic vector. As you can see below, let's say we had X as single, married, married, single. Well, the levels within that are just married and single, right? It's just 2 factors, just like color would be. If we wanted to access the third element, we're using the square brackets again, and we're telling, let's go into this factor, essentially a vector, and say, okay, from this vector X, let's pull the third element. The third element is married. Now, data frames are going to be the most commonly used data structure within R as well as within any type of data science and analytics. The reason for that is because although data frame is similar to a matrix, columns can contain different types of data, such as number, character, and logical. So, if we were creating a database of people's names, their sex, and their age, we could have these different vectors, right? So we have a name vector of Joe, John, and Nancy, a factor vector of sex, male, male, female, and then a numeric vector of age, 27, 26, 26. And what we can do is use the data.frame command to bring these together. Now the data frame has to have the same number of rows and columns. As I just mentioned, data frames are created using that data.frame function. Now an important thing to note is if you're wanting to use strings as factors or not. So if you have strings as factors set to false, something like sex won't transpose as a factor. It will just show as a string MMF. If we had strings as factors set to true, those character vectors would end up being factors themselves, and so they can be grouped more appropriately and are easier to do analytics on. Now, one of the best things to know about using R is subsetting or extracting information from different columns. And so the data that you might want to access or subset can be done using the $sign. So in this case, we're using the data.frame command. Name is the name of the data set, then use the $sign and the variable name. So here we subset name age and name sex from that list, and we're printing those results. Now, lists are the most complex data structures. The rationale why is because the lists themselves do not have to be of same length to join them together. A list is a vector that can also contain elements of different types. In addition, a list may contain a combination of vectors, matrices, data frames, and even other lists. So here, what we could do is actually combine a vector and a matrice itself into a list. Now, lists are created using that list function, so you can try out this syntax yourself. Again, using the vector and the matrix that we created, we can create a list from that and print that information. Now, list elements can also be used by indexing. Again, we're using the square brackets to do so, and the vector that we might want to access can be an integer, character, or logical vector. So, in regards to identifying data structures, for the most part, a data scientist is going to work on a data set that's a blend of character, numeric, factor, strings, anything you can think of. So let's say the data is related to direct marketing campaigns of a banking institution, and you have to identify what these data structures are within that data set. Well, let's take a look at how these data structures can be identified.